Dear students, let us start the chapter 6. The name of the chapter is Electromagnetic Induction. So in this chapter, we are going to study the production of electricity, generation of electricity due to magnetic field. Induction means production or generation. So electromagnetic, two words is there, electromagnetic, electricity and magnetism. So we study the production, the generation of electricity with the help of magnetic field. So in this topic we only go around the production of electricity with the help of magnetism. To start this chapter, first we have to study the magnetic flux. We have also studied electric flux in chapter 2. We have also defined that the electric flux is the total number of electric field lines passing normally through any surface is electric flux. Similarly, magnetic flux is same. The total number of magnetic field lines passing normally through any surface is magnetic flux, and it's denoted by phi. So this can also be denoted by phi of B, magnetic flux due to magnet. But we don't write this notation, but if you are referring some other book and if you get phi B, do not get confused, all of them are same. So let us find the mathematical relation of magnetic flux using this diagram. So this is a circular surface area, and this ds is its area vector. And for example, if this is my surface like this, tilted like this, and this is my surface area vector, or this can also be written as dA vector depending upon the author. So, and one more thing we have to study, that is this area vector is always perpendicular to this surface. This cannot be stand like this, this cannot be stand like this, this cannot be stand like this. This area vector has to be like this, okay, in perpendicular to this surface. That is very important, which we have already studied in chapter 1, okay, Gauss application. And I will put one more arrow which denotes n cap, which is a normal vector. Normal vector is a vector passing normally through the area, okay, that is not a problem. Now to study magnetic flux, we have said there should be number of magnetic field lines passing through this surface. It means that now we have to consider the magnetic field lines. So let us consider the magnetic field lines like this. So this is my magnetic field line, say B vector. This is my magnetic field line, say B vector. Some more magnetic field line here. From the definition, we have said the flux is the total number of magnetic field lines passing through the surface. But here, this is not passing through the surface. This is not passing through the surface. It means that we cannot term these two magnetic field lines are involved. They are not involved in the magnetic flux, because to involve in the magnetic flux, this magnetic field lines has to pass through the surface, okay. So now if we see here, this is my dA vector or ds vector, and this is my magnetic field vector. If you see, there is an angle between this vector and this vector, which is my theta. So here I would like to demonstrate like this, okay. So if you see here, it is just like this. It is tilted like this, okay. And this dot pen represents the magnetic field lines. This represents the dot pen represents what? ds, that is area vector, and this pencil, This pencil represents the magnetic field because it is passing like this. Now there is some angle between this dA vector, ds vector and this magnetic field lines. This angle is theta. Okay, this angle is theta. So the mathematical form of magnetic flux, I will write this as d phi is equal to v vector dot ds vector. So the magnetic flux can be defined as the dot product of magnetic field and the area vector. So this is my dot product, okay, and we know that dot product is a vector dot b vector should be a b cos theta. So similar to this, then what do I get? I get d of phi is equal to b d as cos theta. Very important. These two are very important to understand. Okay. Here you can also write n cap, no problem. So these two are the mathematical form of magnetic flux. B d as cos theta. Where did I get this from? I get this from A dot B dot product. Okay, B dot ds, that is AB cos theta. So B ds cos theta. And what is theta here? You have to write this theta is angle between magnetic field and ds vector. So this is the mathematical form B ds cos theta. B ds cos theta you have to understand. Okay, in chapter 1 E ds cos theta. This is B ds cos theta. In chapter 1 electric field was there. So E ds cos theta. In chapter 2 magnetic field is there. So B ds cos theta. Very important, very easy. So let us go to the SI unit. SI unit of phi. That is magnetic flux. So if you see here, this B is there, magnetic flux is equal to B ds. So B is magnetic field and its SI unit is Tesla, that is T. And if you see here ds, that is area, and the area have the SI unit meter square. So this is my meter square. So we can also do it from this equation also. Magnetic field Tesla SI unit, ds meter square SI unit. What is cos theta? Cos theta is a ratio which is a number, and number do not have any unit. So there is one more unit or which is called Weber, W-E-B-E-R, and this Weber in short form we write capital W and small letter b. What is the SI unit? SI unit is Tesla meter square or Weber. And what kind of quantity is this? Vector quantity or scalar quantity? Magnetic flux is a scalar quantity. Scalar quantity. Okay, scalar quantity exam में पूछता है. For example, what is that unit whose SI unit is Tesla meter square? Is it a vector quantity or a scalar quantity? Then you have to answer the unit which have SI unit Tesla meter square is magnetic flux, which is a scalar quantity like this. Okay. So on what factor? Next is on what factor the magnitude of this magnetic flux depend. Okay. Factors. On which factors the magnitude will depend? Number one factor is the magnetic field. Okay, number one, very important. Number one, it depends upon magnetic field. If the strength of the magnetic field is large, then the flux will also become large. Number two is ds, that is area. If the area is large, then magnetic flux will become large. Number three is number of field lines passing through surface. Okay, if the number of field lines passing through the surface is very dense, very large, then magnetic flux is large. Example, here only the 3, say 4 number of field lines are passing. Now if there are some more lines like this, like this, like this, then that time the magnetic flux will become large. Okay, if the number of lines is passing through the surface is large, then the magnetic flux is large. Number 4 is orientation. Orientation of surface and magnetic field. So what does this mean? Orientation means the theta, that is angle. It depends upon the angle between magnetic field and the area vector. Example, let us consider this. So one of the quantity is this magnetic field, and this is area vector. This is magnetic field and this is area vector, and I have got the angle. Now if I go down, 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 then what is the angle? It is 0. Okay, that is when the angle, that is theta, is equal to 0 degree. What will happen? Then d phi is equal to, this is b ds cos 0 degree, which is equal to b ds, because this cos 0 is 1. So when the cos 0 is 1, then this is maximum. Okay, we have known that if the cos theta is 1, then this is the maximum value. BDS is the maximum when angle is theta. Now, next case, let us go. So this is the magnetic field and this is the area vector, and it is angle is 0. Now if I go up like this, then what will happen? This angle has become 90 degree. Now when the angle is 90 degree, that is when the theta is equal to 90 degree, then this d phi is equal to b ds cos 90 degree, and cos 90 degree 0, that is this is equal to 0, that is minimum. Okay, so we also studied what are the conditions for maximum and minimum values of magnetic flux. There are some more points which are very important, like sometimes this flux will become positive. Okay, this flux will become negative. Okay, so in the next lecture we are going to study when this magnetic flux will become positive and when this magnetic flux are going to become negative. Thank you.